Holy crap, man. What a day.
Yeah, that
was a tough one. What else Sproinky's doing?
Let's go check him out.
Sproinky!
Hey, Sproinky!
Hey, where you at, bud?
Sproinky!
Holy crap!
Sproinky!
Sproinky!
What's wrong, man?
Are you okay?
Oh, looks like Sproinky's not doing so well.
We should probably see about getting him some food. We need to track down some copper, and we need to get the instruction manual.
Yeah, let's get the scroll. The scroll should have everything we need in it.
How to feed your Sproinky. Here are some instructions and background. Feeding your Sproinky is a very sensitive task. You will need to use an atomic absorption spectrophotometer in order to ensure accurate results of copper content in your Sproinky's meal. When electrons of gaseous atoms are excited, they relax by emitting radiation of certain wavelengths. Each element has its own collection of specific wavelengths within a certain series called the emission spectrum. The emitted emission spectrum can be used to identify an element through the process of atomic absorption spectroscopy, in which the aqueous solution containing the particular element is introduced to the heat of a flame burning between 2000 to 3000 Kelvin. This extreme heat causes the matter to break into atoms in a process called atomization. The light of a lamp then passes through the flamed area and beams are collected on a photodetector. Normally, the most intense line within the emission spectrum is noticed, and the element can be isolated and deemed as present. This method is especially helpful for determining elemental concentrations of many samples and is accurate and precise. But one must be wary, for if contaminants are present, this can cause interference where the signal portrayed by the flame provides false results, even though the concentration of the analyte remains constant. Danger. A Sproinky must be fed a solution containing no more than 9 parts per million copper-2 aqueous solution. Failure to do so may result in Sproinky fusion. Tells of a way where one can determine the concentration of an unknown contaminated solution? It tells of a way where a set amount of an unknown is added to multiple flasks, and increasing amounts of a determined standard are then added. In such a way, any errors arising from distortions due to contaminants can be compensated for, and they will be compensated for. We shall graph our results. We shall create a trend line. We shall extrapolate it. From this extrapolated trend line, we shall determine the proper concentration of the copper-2 aqueous solution. We shall then use this accurately measured solution to feed the deteriorating Sproinky.
first need to prepare a standard solution of copper. The Sproinky instruction stated that we required 9 parts per million. If we add a specific weight of copper and add a certain volume of water for a known dilution, we should be able to devise a graph and extrapolate the trend line on the x-axis. If we do this, we should be able to tell the copper content of an unknown solution, and it will be much easier to determine the correct concentration of the Sproinky flue solution. Yes, now all I have to do is follow the instructions. Add 0.15 grams of copper. Okay, now add nitric acid. Perfect. Now the metal is dissolving. I can dilute the standard solution by a factor of 100. Now if I add 1, 2, 5, 7, and 10 milliliters of solution to the standards respectively, I will have enough diluted samples to form the trend line. Excellent. And by using the AA spectrophotometer, I can measure the absorbance of the standards, verify the absorbance levels on any unknown solution, and determine the copper content to feed Sproinky. And what are the figures? The trend line is giving me a value of 0.0307. Okay, now the line is passed in the y-axis at 0.0924. Good. Y-intercept divided by extrapolated x-intercept. Diluted standard solution concentration multiplied by volume by extrapolated x-axis volume should give me a weight of copper found to be 4.5 times 10 to the negative 5 grams of copper. This means that there is the same amount of copper in 0.0307 milliliters of standard solution as there is in my unknown sample. Do the math. What is it? My unknown solution, what is it? Mass over volume, 0.009 grams per liter. Well, that's 9 parts per million liters. That's 9 parts per million. Eureka!
Oh no, Sproinky's dying. What could have gone wrong?
Did we measure everything properly?
Perhaps we weren't accurate enough in the dilution process.
Perhaps the calibration of the spectrometer was off?
Whatever the case may be, our 14% error was a little too high. The concentration of copper was too much for poor Sproinky.
Oh, poor Sproinky.
Death of Sproinky. Poor Sproinky.